All right, we are now moving on to liquid waste. So, not all waste is solid waste. So, there are two major strategies to this, and it's either, I think I've heard the solution to pollution is dilution, and that is to dilute and disperse. That if you dilute it enough, just add more and more clean water, eventually that little bit of like bad is so negligible, it's not going to hurt anything. Um, or it's kind of the opposite, where you can say concentrate and contain. So where you get it as concentrated as possible and then put it someplace where it's not going to spread out. And so these are two ways we handle our liquid waste. Examples of liquid waste would be from industry processes, as shown here. I don't really know what this is. I don't think the book said either. It just said picture of red waste. And sewage that we'll be talking about. So we can do secure landfills for this, and this comes back to like we were talking about earlier with the impermeable zones. And so you can see here that they have this in clay. Clay is very impermeable. And then we have a plastic liner, which is also impermeable. And then all of this is covered again with more clay, and they've even put it so they have like a layer of waste and then clay on top, a layer of waste and then clay on top, and so forth. They have these little pipes in here to let gases vent. You can see the methane where they're actually collecting the methane from this. They can use that for another, source of fuel for heating and things. And then if it starts to fill up with water, then they can collect the water through these tubes as well to try to keep everything contained in here. And then when it's all done, they just put soil on top of it. Let's see. They put it in sealed drums when they do this. So, well, because liquid would just flow around, so it's a lot cleaner if you put it in these sealed drums. And the idea is to ensure the leachate will not migrate. Other than the sealed drums, we have liquid waste disposal in our deep injection wells. And so this is where we just put the waste into a permeable layer that's so deep into the ground. That is also controlled by impermeable layers. So in this example, the liquid waste is not going to flow out of this stratigraphic layer right here, because above and below we have shale, and shale is impermeable. Also, we do it really deep, because the deeper you go, the saltier and saltier, just naturally more dissolved things are in the water. Not just salt, but there's borates and all sorts of things, which technically is a type of salt, but it's not like the table salt you're probably thinking of. So the saltier the water is, the more dense it is. So the fresh water is going to be floating above the non-fresh water. So the deeper we go, the more we're going to get into groundwater that will never be used for drinking water purposes. So that's the idea behind it. Now, obviously, this looks really good here, but what happens if, a mile over here, there's a fault, and now you're letting this stuff come up that fault. So it also is not perfect. Here they're showing natural structures trapping the waste. So this is an anticline, and this would be for waste that is less dense than the water around it, where it would float to the top of the anticline. And so they can look at the geology and say, okay, well, we'll put it right here, and it's going to contain it. That way it's not floating out forever and ever and ever. It's staying within this local anticline area. And for waste that is more dense than the surrounding water, it's going to sink to the bottom. So you can put that in a syncline, which is, I don't know, I guess we haven't gone over anticlines and synclines yet. Anticline is when it's been folded and it goes up. Synclines when it's been folded and it goes down. A lot of times you can find these in folded belts, and it just kind of, they're next to each other. And so the heavy stuff will kind of sink into that anticline like a bowl, and then it's kind of trapped in that bowl. It won't be able to come up and migrate very far laterally or horizontally out. Yes, and they're expensive. And I don't know why it says unsafe. I guess because of like things you don't know, like what if there is a fault or something? You know, we just really don't know. We can use seismic, we can use other drills. Also, you have to make sure that when you drill, obviously you're poking a hole through the barrier rock. So you have to make sure that you are fully cementing the backside of the casing here so it doesn't come back, so the contaminant doesn't flow back up out into like the drinking water source on the backside of this well you've just drilled. And then you have to securely cap it too, because again, you don't want pollution from the surface coming in this little hole you've dug and getting into the water table either. Other strategies, incineration, like we mentioned before, it still produces carbon dioxide, so it's not a complete fix-all. And then we can treat using other chemicals or biological agents to help maybe neutralize some of the toxins so that it's not so bad. Or just reduce the volume as well. But even then, we still need proper storage for it, either in the place that we are treating it, or if we have just reduced the toxicity of it, it's still toxic. It's just not as bad. So we still have to find a place to dispose of that last bit. Baby, I'm doing a recording, so hold on, okay? But Dylan, no, Dylan, I'm doing a recording. Hold on. Sewage treatment. Okay. Septic systems. So this is what happens in your backyard if you're not tied to like the city sewage system. It uses a leaching field. And really the concept behind this is that the bacterias and things in the soil just kind of will naturally remove all of the yuck in your sewage waste. So with that, you have to have it so high above the groundwater, because if it's too close, obviously it will filter down before it's been thoroughly treated and end up in the groundwater. And you have to have enough space for this to work. So you can't put too many of these close together. You're going to overload that natural system in the soil. And it has to be large enough. And so in here, it's got like a settling spot that lets the solids settle to the bottom. This is like your septic tank here. And then it has these pipes, and they have holes in them. They're perforated, and it lets the water out. And then the water is treated by the soil. What does it say here? Microorganisms and oxygen break down the organic matter in the waste. And so by the time it does flow on elsewhere or eventually down into the groundwater table, then all of these microorganisms in the soil should have effectively cleaned it up. Just taking advantage of natural systems.
A snail.
No, you can't have that. Dylan, go put that back outside. You're not keeping a slug. Outside. Dylan, and you're interrupting my recording. I told you. Go. All right. Now, like I mentioned, you can't have too many in like one spot, because then there's not enough bacteria and stuff in the soil to treat everything. So if you're in a city, you're not going to have a septic tank. You're going to have a city sewage treatment plant, where they kind of try to take advantage of the same concept, but they have to force everything into man-made facilities. And so the first step here is the removal of solids from organic liquid waste. So anything that's like accidentally washed down the drain or something, pieces of trash, all that, gravel, anything is going to be filtered out. Then they let the bacteria and the fungus dissolve the organic matter, much like what would happen naturally out in the soil in your backyard or out in the forest or something. And then they hit it hard with like the chlorine or UV or whatever else they're doing to try to make sure that everything is killed. So all the diseases and bacteria and stuff, they want to make sure it's as clean as possible. Yeah, and so here's just an example of that. And that is it for our liquid waste.